Hey folks, welcome back for another year of Advent of Code in F#. Before we get started and dive into the puzzle, let's give a quick introduction to this series, shall we? And I'll even put myself on the rare full screen for this. So what is Advent of Code? Let me grab the text from the official website, adventofcode.com. Advent of Code is an advent calendar of small programming puzzles for a variety of skill levels that can be solved in any programming language you like. So it's real fun if you are learning about programming, or if you program here and there and you want to challenge yourself with a bit of puzzle action. It's a great way to spend your mornings or your evenings in December. And it's the 1st of December today, so the puzzles have officially started. We are going to do it in F#, so if you are learning F# or you're interested in the language but have not really seen it, this series will be a very good introduction as well, because we're going to touch upon a lot of the concepts of the language. I like to make it a bit more difficult for myself at least, and I apply a little bit of extra sprinkling, extra constraints, so I try to only use the purely functional part of F#, no classes, no interface, no mutable state, stuff like that, and see how far that gets me. I think there's one or two edge cases where I have to grab from mutable state because of performance reasons, but let's see how far we get this year without. And without further ado, let's dive into today's puzzle, shall we? I had some technical difficulties. This is take 2 already, so I have actually already solved it once before. This will not be a live code. I know all the spoilers that are coming, but it's day 1, it's a short one, so I thought, hey, why not re-record the programming session. So here we are. I'm not going to read today's puzzle. I invite you to look it up yourself if you're interested. It's always got a good story. This year we're helping a historian, or we're trying to find the chief historian. And as always, we are collecting silver and gold stars. Today we were given 2 lists with numbers, and we have to sort those 2 lists for part 1 from smallest to largest, and then pairwise compare the differences, and we have to sum up those differences. So that's a pretty doable first part of the exercise. So let's dive right in. For those of you who have seen the previous iterations, yes, this is Rider, this is not Visual Studio. I finally listened to you all, and it's an improvement. This is officially the better IDE for F#. There, I said it. So yeah, let's get started here. This is my usual setup, maybe because it's day 1. Let's take a look at what we're doing here. You see FSX files, that's script file, so that's not part of a binary that you compile. That's just a notebook kind of thing where you type some code, you select the code, you press the shortcut, and you evaluate that code. You just select it. So it's a very interactive way of programming, and it's ideal for puzzles like Advent of Code. So I already grabbed the example, as you can see here. And let's start by parsing that example into 2 lists of numbers, because that's what we need to proceed. Parsing is always just taking a line, munching the data, so let's do that. I'm going to write a parse function that takes input. The input is a string. And we are going to map over, we're going to use lists modules map. We're going to use a map to grab every line and parse the line. Parsing the line, we can do that ourselves. Sorry, input is a string list. My IDE is telling me it's a string list, not a string. So I already did some minor parsing here. I split the string into lines. So these are the lines. Let's see if these resharper shortcuts work in IDE in Rider. I have 0 experience with Rider, so if I'm finding my way around, that's part of this year's stream. It's me learning Rider as much as it is about showcasing F#. But anyway, let's continue parsing. Let's split on whatever this delimiter is. It's a couple of spaces, I guess. I think this parses our lines. or at least splits every line into 2 parts. And then let's take, well, what does the split return? Split returns an array of strings. So we can map over that array of strings. And that's a number. We can just parse the numbers, and that should give us our raw data. Why is there a green squiggly line? Lambda can be replaced with int. Oh yeah, int is a single argument function, and we're wrapping another lambda, single argument lambda around it. Let's see if alt enter works. Yeah. Okay, cool. Already loving it. So this should give us an initial parse. We're almost there, I guess. And let's parse the example. Yeah, that looks good. So we're pairwise parsing. That looks exactly like what we need. But now we have a list of 2 element lists, and we would like 2 lists of the columns. And I think there's a reason. I don't think I have already tried this, but there's a transpose function. I think it's pretty new. And that transposes a matrix, or it transposes a list of lists. So that's exactly what we need. And then we have our 3, 4, 2, 1, 3. So that's correct. But everything here is a sequence, and I prefer working with lists. So let's try to transform this to lists. We need to make the inner sequences lists, and we have to make the outer, or maintain list type of the outer. So I think this should work. There we go. We have a list of lists, and it even looks correct. So that is our parsed input. Let's destructure those 2 lists into the first and the second. So this should work because we know it's 2 and exactly 2. Yeah, so we have first in the first variable and the second list in the second variable. Now we just need to sort both. Yeah. I'm gonna call them sorted first. And we can use the order. No, it's called sort, sorry. Is it? We need to go from smallest to highest, right? Yeah, we have to go sort ascending, that's this one. Correct. And we have to take the second one, the sorted second. And let's try out the writer refactoring tools. Can I rename this with shortcuts? We can. I think that's already proving that it's the better IDE for F# programming, which is a bit sad, but true. So there we go. We have our 2 lists, and now we just need to calculate the pairwise distances. Yeah, we need to calculate the pairwise distances. And for that, we need to smoosh those 2 sorted lists back together. And that is, you can do something like that, smooshing 2 lists into a single list, combining tuples of both with a zip function. As you can see, the function signature here says it takes list 1 and list 2, and it returns a new list of tuples of the 2. So it's a pairwise smoosh of these 2 lists, which is exactly what we need. Let's run that so you can see what happens. So this is the first element of the first list, first element of the second list, and so on. So this is every pair we need to take into account, and now we just calculate the differences from one and the other, and we calculate the distance, which is the absolute value of one minus the other, and that should give us the distances. And if we sum every distance by using list.sum, we get 11, which is what we are expected to find. Let's verify by running on my input instead of on the given example. It's giving me 2, 3, 6, 7, 7, something, something, and that is correct. So part 1 down. Good job, us. Hey! I'm just going to copy part 1 into part 2, so we can forget about part 1 and start hacking away. The second part is a bit of a variation. What was the second part again? Oh yeah, We don't need to sort anymore. We need to take a look at the original two lists. And for every number in the first list, we have to count how many times it occurs. So for example, this 3 occurs 1, 2, 3 times. And the 3 times we multiply with the original number, 3 times 3, and we do that for every number. So 4 appears once, so 4 times the 1 of the ones equals 4. We do this for every number in the first list, and we have our answer. So that's the principle. And I'm gonna do it a bit differently than I did in my first attempt. I did the naive, just loop over the list every time. I'm gonna do it a bit more fancy because I've had a couple of hours to think. And I don't think it's that much harder, so let's make it a bit more interesting. We still need to parse. Yeah, we don't need to sort, so let's throw everything away after our parsing. And let's continue with our original two lists. I'm going to use the example instead of the input, or instead of my input. So yeah, we need to loop over every element in the first list and count how many times that number occurs. They are not going over the sorted lists. 3, 4, 2, 1, 3. No, okay, so let's not sort anymore either. We need to count how many times each number occurs in the second list. So I'm thinking let's make it a bit more spicy and let's make a smarter data structure to answer that part of the question. Like how often does the number 3 occur in the second list? Let's make a lookup table for that. So we take our second list and let's do a count by. Count by takes a projection that takes an element takes a function that's a projection, and that function takes an element of the list and returns a key. And it counts everything with the same key and it returns a tuple saying, okay, that key occurs that many times. So I think if we just do count by ID, it will count every number and group, it will list every number and the times it occurs in the original list. So for example, the second list, let's print it out again. There it is. 4 occurs once, 3 occurs 3 times, 5 occurs once, and 9 occurs once. That's how we can interpret this count by ID result. And to make it even more spicy, let's make it a lookup table, which is called a map. It's the C# dictionary. So now we have a lookup table. I'm gonna call it LUT. No, let's call it lookup table. Let's call it number counts. So it maps numbers to their counts in the second list. Great. Now we only have to loop over elements in the first list and figure out how often it occurs. So we can do that with a map as we did before, or we can do something spicy and something different. And I'm going to do something spicy and something different called a for expression or a for comprehension. It looks kind of like a for loop in traditional languages, but instead of being like a control flow thing, it's something that returns values. So it's similar, but not exactly the same. But let's go ahead. For every element in the first, we do something, we return the lookup of the number, and I'm using map.tryfind because not every number will be in the second list, so not every number will be a key in the dictionary or in the map. And tryfind works with that. You can it cannot be there by returning an option. And an option is like a box and it can contain something, which is the sum case, or it can like not contain anything, which is the none case. So now if you look at what this for expression returns, it's giving me a list of options. Some are some are some, and some are none. Those nones actually should map to 0 because we have a count of 0 for those numbers, and all the other ones is just the value in the option or in the sum. So let's continue with the functions in the option module, and you have several. You have option bind, you have option default, which kind of take the value from the option, and if it doesn't have a value because it's a none, you can provide a default value, which is kind of what sounds like something we could use right now. So this is saying gets the value of the option if the option is sum, otherwise returns the specified default value. That sounds exactly what we need. Let me take a look at this default width. I have no idea what this does. Okay, that's like if you want to give a function that generates the default, but we know what the default value is. We don't have to calculate it. So this is 310033. 310033, that's correct, but I forgot that we have to multiply with the original number. Okay. Yeah, we have to remember element, so we're looking up element. But we kind of need to remember element as well. Or we can do wrap the entire thing we return in a tuple containing the element and the result and the count we just calculated. So this one-liner, this very dense line of code is telling me that 3 occurs 3 times, 4 occurs once, 2 0 times, 1 0 times, and so on, so on. So those are the counts we need. And now we can do the same. We can just map over every element. Oh, list.map, I mean. And that's a tuple. And we can multiply the elements of the tuple and again sum every product we have. This should be the result. So it's 31. It's 31. That seems correct. Let's run this on our input. 2 1 2, and that looks correct. Great. This went a bit faster than my first attempt. I think I took 30 minutes the first time around, so I'm happy to have spared you a bit of your life. Did not waste your time. So let's do a quick recap. What did we do today? We did a lot of parsing, and the interesting part for me at least was that the two lists were not two lines in the input. We had to flip, we had to transpose, and there's a handy transpose function in F# you can use for that. And other than that, it was not really super interesting, the first part. It was just sorting and calculating distances. So we have been there before in the previous years. For part 2, that was a bit more interesting because we had to do a bit of counting. And we did it with a very dense one-liner, as you can see here. We used 4 comprehensions, we used maps, we went all out, wow, and we used options. So this is maybe a bit overkill. It's not maybe, it's definitely a bit overkill, but it works. And I kind of like the feel of this one better than my first attempt, so I'm just gonna commit this one. So yeah, that's day 1 down, 24 more to go. I hope to see you tomorrow for more Advent of Code in F#. Thanks for watching. Bye bye.